Let's consider how we can evaluate a multi-class classifier now using the concept of confusion matrices, but extended so that it works for multiple classes. So here's an example of a confusion matrix for an image classifier that is designed to classify 4 different classes of flowers. We're going to use a color scale here to highlight the differences in values. And let's start by taking a look at the tulip class. Once again, as a row, we see that there are 10 actual images of tulips that we're testing the classifier with. And when we look at the column for tulips, we see the number 9 that intersects both the row and the column. And that is indicating that we had 9 actual images of tulips that were correctly classified as tulips. So these are known as true positives. True because they are correct, and positive because they were classified in the class that we are measuring, which are tulips. Let's look at the other number in the row here, which is the 1. And here we see that there was 1 image of tulips that were incorrectly classified as a rose, and we did not incorrectly classify any other images of tulips as sunflowers or daisies. So that means we had 1 incorrectly classified image of a tulip, and this is known as a false negative. It's false because it was incorrectly classified, and it's negative because it was not classified as a tulip, which is the class we are looking at. When we look at the other numbers in the column for tulips, we see that there are a total of 4 images that were classified as tulips, even though they were not actual images of tulips. So these 4 results are known as false positives. False because they were incorrectly classified, and positive because they are belonging to the class that we're looking at, which are tulips. So when we look at all the other numbers and total them up, we see that there are 26 results, and these are known as true negatives because they were not classified as tulips and they were not images of tulips. So they're known as true negatives, true because they were correctly classified, and negative because they were not classified as a tulip. So notice all of these statistics are all in relation to the tulip class. Now let's take a look at the rose class. So for each class, we're going to generate those 4 same statistics. So looking at the row, we see we had 10 images of roses to test against. At the intersection of the row and the column, we have 4, which is indicating that 4 images of roses were correctly classified as roses. And these are true positives, true because they were correct, and positive because they belong to the rose class. The other 6 images of roses were incorrectly classified, and so these are false negatives. False because they were incorrectly classified, and negative because they were not classified as a rose. When we look at the column, we have a total of 4 false positives, which weren't images of roses that were classified as roses, so false because they were wrong, and positive because they were classified as a rose. And then all the other ones are true negatives, totaling 26, true because they were correctly classified as not being a rose. So in the ideal case, we would have a confusion matrix that has only numbers along the diagonal going from the top left to the bottom right, just like how we saw for the 2-class situation. And to summarize, for each given class, we had 4 statistics that we looked at: false positives, false negatives, true positives, and true negatives. The false and true part refer to whether the classification for that class was correct or incorrect, and the positive and negative part refers to whether the classification belonged to that given class or did not belong to the given class.